Hello everyone, welcome to In 5 Minutes. In this video clip, we are going to discuss a modified version of pulse code modulation. It is called Differential Pulse Code Modulation or simply Differential PCM. In pulse code modulation, we convert an analog signal to the digital signal and transmit the digital signal to the receiver side. If you remember, in case of pulse code modulation, we basically send the signal through two important processes. The first one is called sampling process and the second is quantization. Sampling gives us the discretization of the time variable in the signal and quantization gives us discretization of the amplitude variable. And that's how only when both the independent time variable and the dependent amplitude variable are discretized, we can achieve perfectly digital signal, which is written in the form of ones and zeros. Now let us try to understand what is this new version of PCM, which we have called as differential PCM. We'll first go through the transmitter and the receiver, and then we'll try to compare differential PCM with pulse code modulation. So as you can see, we are taking the modulating signal m of t, which is given to the sampler. So the very first step of sampling is exactly similar to PCM. Whenever a signal is sampled, we use something called as a sampling frequency, which is, let us say, Fs. The value of Fs must be chosen as per the Nyquist sampling theorem, which has to be greater than or equal to twice Fm for low pass modulating signal. Fm will be the maximum frequency or bandwidth of the low pass signal. As you can see, the next block is the delay block, and after the delay block we have a subtractor which takes the two inputs, the two values which the subtractor is going to subtract. The output will be the difference between the two values. Now let us try to understand which two values the subtractor is going to subtract. Let us say the first sample arrives at the output of the sampler. You can see it goes as it is to the first input of the subtractor. It also goes at the input of the delay block. The delay block will provide the delay of Ts seconds. Ts is the sampling time period, which is 1 upon Fs. So as the first sample arrives, it goes to the delay block, it goes to the input of the subtractor also. Because it's the very first sample, right now, we don't have a defined output of the delay block. So we simply discard the first sample, and now after Ts seconds, the second sample will arise at the output of the sampler. This second sample is given at the first input of the subtractor now. And as you can see, after Ts seconds, the first sample which was given at the input of the delay block will also be available at the output of the delay block. So basically at the inputs of the subtractor, you have got first sample which was delayed by Ts seconds, and hence it is there at the output of the delay block now, which is input to the subtractor. And through this direct connection, we have the second sample available at the input of the subtractor. So the output of the subtractor is going to be the difference between the first sample and the second sample. So if I take some numbers to understand this whole thing, let's say for example the first sample comes out to be 4.5 units of value. It goes to the subtractor and also the delay block. After Ts seconds, let's say the next sample comes out to be of 4.2 units. In that case, the first sample is available at the output of the delay block now of value 4.5 units, and the second sample is available at the input of the subtractor through this direct connection, which we are assuming to be 4.2 units. So the output of the subtractor is going to be 0.3, and this 0.3 is given to the quantizer as well as the encoder blocks. So if you now compare this transmitter with the PCM, you can see there were no delay blocks and subtractors. We had sampler, we had quantizer, and then the encoder. So if it was standard conventional pulse code modulation, we would have quantized 4.5 first and then 4.2. But now instead of that, we are quantizing the difference between them, which is 0.3.